Parallel axis theorem. Today we are going to learn parallel axis theorem. Why we need to learn these two parallel and perpendicular axis theorems? Because if you know these two theorems, you can calculate the moment of inertia of any object, whatever may be the axis of rotation. For example, this is an object, cylindrical body, or this is a rectangular wooden plank. They are giving the axis of rotation about one point. They are asking us to calculate the axis of rotation about some other point. So, depending upon the situation, you can apply parallel axis theorem or perpendicular axis theorem to calculate the moment of inertia about another axis. So, to simplify that, you can calculate the moment of inertia of any object. For example, this is an object. This object is rotating like this. This is axis of rotation. The calculated moment of inertia about an axis passing through this edge. They are asking us calculate the moment of inertia about any other axis or about an axis passing through center of gravity. Then apply parallel axis theorem to calculate the moment of inertia about center of gravity. Or sometimes they are giving this lamina is rotating like this. Now calculate the moment of inertia about any other axis or about an axis perpendicular to its plane. Then you apply perpendicular axis theorem. What is lamina? The thickness of any object is negligible when compared to the surface area that object is called. We can call it as lamina. Lamina means all the masses are lying in the same plane. If you take this paper, each and every particle lie in the same plane. All these particles are lying in xy plane. Let us imagine our board is in xy plane. So all masses of this object lies in the xy plane only. Okay. According to parallel axis theorem, first we consider lamina. This lamina is rotating about an axis, about z axis, passing through the point O and perpendicular to plane of the lamina. Now let it be the center of gravity of this lamina. Initially this is the z axis. You consider another axis parallel to the first one, that is parallel to z axis, and it should pass through the center of gravity of the lamina. Whatever may be the position of the first axis, you can take this z axis here, 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 anywhere. You can take initial axis of rotation anywhere else, or here also at the edge also you can take here or you can take here. But the second parallel axis must be, for example, the first axis you considered here, the second one must be parallel to the first one and it should pass through the center of gravity of the lamina. So for our convenience, I have taken the one axis at point O, the other axis passing through the center of gravity. These two are two parallel axes. Now you can draw second axis z dash like this. Let cap A, small a is the distance between these two perpendicular axes. We have two perpendicular axes like this. Sorry, two parallel axes like this. The distance between these two is A. To calculate the moment of inertia of this lamina, the moment of inertia of the lamina about z axis, Iz is, the moment of inertia is equal to sum of moment of inertia about center of gravity plus total mass and the perpendicular distance between two parallel axes. The moment of inertia of a lamina about an axis perpendicular to its plane is equal to sum of the moment of inertia about the center of gravity and the product of mass and perpendicular distance between two parallel axes. To derive this, consider a particle P having mass m here. Join OP, let it be capital R, and join PG, let it be small r. Now extend this line and draw normal from P. N is the foot of the perpendicular. Here we have two right angle triangles. ONP is one triangle and GNP is other right angle triangle. Okay. Now from the first triangle, ONP, I will explain you in brief. Initially, z-axis is the one passing through the point O and perpendicular to the plane of the lamina. You consider another axis z' passing through center of gravity and should be parallel to the first axis. Now, A is the distance between, small a is the distance between two parallel axes. Consider a particle of mass m at point P. Join OP. The distance from O to P is R. Join PG. Let it be small r. Now extend OG and draw normal from P. PN is the normal drawn to OG. Okay. We are extending OG here like this and draw normal like this. Okay. Now we have two right angle triangles ONP and GNP. First take ONP. Apply Pythagoras theorem, diagonal square. What is diagonal? OP. OP square is ON square plus PN square. ON can be written as OG plus GN because we don't know the value of ON. So OG plus GN whole square plus PN square. Now expand this. We know that OP is capital R. So R square is OG square GN square plus 2 OG into GN plus PN square. Let it be equation 1. Now take another triangle. From the triangle GNP, again apply Pythagoras theorem. GNP, this is diagonal GP. GP square is GN square plus PN square. Substitute this value in equation 1. Instead of GN square and PN square, write GP square. Now 1 can be written as, equation 1 implies R square is OG square. Instead of GN and PN, write GP square. GP square plus 2 OG into GN. What is OG? A, distance between the two parallel axes, A square. What is GP? G to P is R, small r, R square plus 2 OG into GN. Now take sigma m both sides. Multiply with sigma m. Sigma m is total mass of the lamina. Sigma m into R square is sigma m into A square plus sigma m into small r square plus 2 sigma m OG into GN. Okay. Sigma m into R square is moment of inertia about, because capital is the distance from z axis. You can write this as Iz. Sigma m is nothing but total mass of the lamina, capital M, and A is the perpendicular distance between two perpendicular or distance between the two perpendicular axes, plus 2 sigma into r square. What is small r? Distance of the mass from center of gravity. Let it be that sigma m is capital M into r. Center of r is the distance from center of gravity. So this is the expression for moment of inertia of the lamina about center of gravity. The effective mass and the distance from center of gravity, square of the distance. R square is the square of the distance of the mass from center of gravity. So Ig. The last term you can neglect it because the vector sum of momenta about the center of mass is 0. That's why this term value becomes 0. You can neglect it. So Iz equal to Ig plus Ma square. What is Iz? Moment of inertia of the lamina about z axis is equal to the sum of moment of inertia about center of gravity and the total mass and perpendicular distance. Product of mass and perpendicular distance between two parallel axes. These two theorems, parallel axis theorem and perpendicular axis theorems, are very important in examination point of view also, and also while solving problems in MCET, NEET, IIT, we have to apply these theorems while solving problems. That's why this concept is very important to learn. Everyone should learn parallel axis and perpendicular axis theorems. Thank you.